Alright, hell yeah, I'm making shorter videos, and this is on uncertainty, and this is real simple. Yeah, it's not simple, but it's real simple. Alright, so you have a 10-inch length. It could be anything, you know what I mean? And it has an uncertainty of 1 inch. It could be either 9 inches or 11 inches. This is how we write that. 10 inches plus or minus 1 inch. Now, what is this as a percentage? Well, it's 10%, you know what I mean? 10% of 10 inches is 1 inch, you know what I mean? And so it can also be written as a fraction. And this is 1 divided by 10, that's where you get this number. 1 divided by 10 times 100 is 10%. Now, if we want to make an area, we can just take the exact length, 10 by 10, and you get 100 square inches. But there's a chance that because this has an inaccuracy or an uncertainty of 1 inch plus or minus, we might be measuring 2 9 inches. Two lengths that are 9 inches. There's a possibility. So this area is 81 inches squared, and there's a possibility that when we measured these 10-inch lengths, they both were 11 inches. That's the max these could be, and so they could be 121. Well, that means that the area actually is going to be 100 plus 21 inches, or minus 19. But by rule, how you get when you multiply, a length with uncertainty, when you multiply them, what you have to do is you have to get it into a fraction or a percentage. So now the actual area, by rule, you take this area and then you get you add the percent uncertainty. So 10 becomes 20, 0.1 becomes 0.2. And then once you get the percent uncertainty, you can get the fractional uncertainty, and 0.2 to 100. What's a tenth of 100? Well, that's 10. What's 0.2? 2/10 of 100 is 20. And so you by rule, you get the area is 100 square inches plus or minus 20. But actually, you're going to get 21 inches squared minus 19 inches squared. So what this says, if you measured 10, but the thing is actually 11 inches, your error is going to be more. But if you measure 10 and your area and your length is 9 inches, your area is going to be less. You know, maximum uncertainty is actually going to be just a little bit less. And so this also shows up with volume. So by volume, let's just do it by rule. You're going to take this length, 10 inches plus or minus 1, and you have to convert it to a fractional or a percent uncertainty. Because then once you multiply this 3 times, you multiply the 10 3 times, 10 times 10 times 10 is that 1,000, but then you just add the percent uncertainties. 10 plus 10 plus 10 is 30%, or 0.1 plus 0.1 plus 0.1 is 0.3. And once you get that, then you can find the actual uncertainty. We call this actual, but anytime you multiply or divide, like we said, it's not exactly actual. And I think we can all relate to doing these problems. Now, if you add lengths, let's say I had 10 inches, and then I added another 10-inch one, and it had an uncertainty. You can find the actual uncertainty, because 9 plus 9 is 18, and 11 plus 11 is 22, and then you would be 10 inches plus you would be 10 plus 10 is 20, and then you would add the absolute uncertainty. So anytime you're adding or subtracting, you have to add and subtract the absolute uncertainties. You actually can't add and subtract these, and if you have the same percent uncertainty when adding and subtracting, they stay the same. Your uncertainty stays the same. And that might be just a little bit too much words there. But anyway, so let's go back to this volume. Is that you'll see that by rule, hell yeah, our uncertainty is 10%, and we multiplied this length by itself and by itself again, kind of 3 times. So we have to add those percents, and 0.3 of 1,000 is 300 inches squared. So now we know the actual uncertainty, but what is the exact actual uncertainty? Because 10 times 10 times 10 becomes 1,000, 9 times 9 times 9 becomes 729, and so forth. 11 becomes 1,331. So you're going to have 1,000 plus 331 or minus 271. So here's your actual uncertainty. So by rule, calling this actual uncertainty is kind of a misnomer. It gets you close, it gets you in the ballpark. But anytime you're multiplying, dividing by an original measurements involving length or one parameter, anytime you multiply and divide those parameters, your uncertainty isn't actual. It's close, but it's not actual. It gets us in the ballpark, like right in the middle, you know what I mean? Who cares? But it's just fascinating that all you have to do is take the minimum, whatever parameters you're using in a problem, take the minimum of those parameters, and then solve the problem. Booyah. Take the maximum of those parameters, solve the problem. Booyah. And then take what you thought was the exact length, and then solve the problem. So you solve the problem 3 times, then you can say, what's the difference? Well, it's this, what we thought was actual, plus, our uncertainty on the high end and our uncertainty on the low end. But it's just fascinating that by rule, you add the uncertainties, the percent or fractional uncertainties, when multiplying 2 numbers. And if you multiply 3 of those numbers, then you have to add them 3 times in a row. So anyway, I think this video, you would have to, this is not an introduction to uncertainty, but it shows you this kind of just more of a proof of like, oh, yeah, I always thought something was fishy there. You know what I mean? Because this isn't the actual uncertainty. When you take a length and multiply them together, especially 3 times, this uncertainty is going to build up for sure, and it's going to be different than what you would consider quote unquote actual. And the percent uncertainties, 30% compared to 33 compared to 27. So they do diverge a little bit. And one is that's fascinating, because in this case, oh no, and we're still off by 1. Oh no, but it is still plus 21% minus 19. So even though that these are 1 off from 20, and that these are both 3 off from 20, you still have more inaccuracy on the high side than the low side. So if you did measure something and it was slightly, if there's more probability that it was slightly shorter, your answer is actually going to be more correct. It's going to be closer. 19 is closer to minus 19 is closer to 100 than plus 21. Plus 21 is not as close to 100, even though these are going to be the average right in the middle. So yes, so then I guess so this is an average of your actual uncertainties. If the actual uncertainty says plus halfway in between these 2 numbers is this number. So that's just something that I just maybe just realized. But still, it's still farther away on the high end and closer on the low end. That's what the differences of these numbers, that's what it means. When the number is the same, it means it's the same distance away on the high end and the same distance away on the low end. Alright, well thanks for joining me, and that's a video.